Okay, class. So this is to cover volume and total surface area of cylinders. I know Mr. Lee has covered it, but this is for those who still need to revise. Okay, so as you will know, your example 13, the base radius of a cylinder is 3 cm. So radius is 3 cm. The height is 8 cm. Okay, so find the volume of the cylinder. Okay, so by now you should be very familiar that a cylinder, to find volume, is really just going from 2D, the 2D shape, to 3D, 2D to 3D, 2D. So we find the 2D first, which is the area of circle, then we multiply by height to get the 3D. Okay, so area of circle, right, write this down somewhere. Okay, area of circle, pi r square, right? So since we have r is 3, okay, so it's pi r square, this is your area of circle, multiplied by your height. So they say leave your answer in terms of pi. Okay, so not to complicate the answer, 72 pi cm cube. Then they say total surface area. Okay, so from here we need to go and watch our YouTube shorts, right? So we're gonna look for net of cylinder. Okay, so we're gonna look at this one over here. Right, so we have this center portion. Just to show you how to do it. Okay, this is pretty fast. Okay, so you notice your center area, the giant rectangle, actually comes up and form the sides of the cylinder. Right, so when it's this shape, you realize that the length of this rectangle is your circumference of your circle. Okay, let's look for another video that shows this. Okay, let's look at this one.
What do we have with us? We have a rectangle and two equal circles. This, in fact, is the net of a cylinder. So how can you fold this to form a cylinder? You can do it like this. So now we understand how to form a cylinder from its net. Let's now look at the cylinder and its net. Look at the breadth of the rectangle. This becomes the length of the cylinder. Look at the two circles. The two circles have now become the circular base and the circular top of the cylinder. Look at the length of the rectangle. The length of the rectangle is equal to the length of the circular top and the circular base of the cylinder. So now you understand the concept of the net of a cylinder, don't you?
Okay, so hopefully you can get a better picture. So in any case, we know that our net will consist of two circles, right, and one giant rectangle. The only tricky part is that the length of this rectangle here is always the same as the circumference of your circle, right? Okay, as shown in the video. So from here, your circumference of circle two pi r. Okay, so what do you need to do? First, you need to find the area of two circle times 2, right? Okay, then you need to find your circumference times height, right? So this is your circumference times height to get the area of the rectangle because it's length times breadth. Okay, so we know that r is 3, and then we sum in our values. H is 8. So this will be 9 squared times 2, 18 pi. 2 times 3 is 6, 6 times 8 is 48 pi. Add them together, you will get 66 pi cm squared. Okay, so this is quite easy and straightforward, so hopefully it's not an issue. Okay, example 2. Okay, so this one, they have to ask you to work backwards. So the volume of a closed cylinder is 554 pi cm cube. No, this word here, close and open, right? Actually, for this subject, it just means whether it has a cover or not. So this one has a cover. Okay, so think of your Pringles can, okay, with the cover on top. So this is a closed cylinder, right? There's both sides. There's area. There's area on one side. There's area on the side because there's a cover on both sides. Okay, so this is volume. So volume equals to 54 pi, right? Given the height of the cylinder is equal to the diameter, okay, so height is equal to the diameter. Okay, find the base area of the cylinder. Okay, so base area of the cylinder means find this area here. Okay, since we know that our volume is area 2D of circle times height 3D, become 3D, right? So area of circle is pi r square. Okay, but the tricky part here is that we know because your height is your diameter and your diameter is 2 radius. So your radius is actually your height divided by 2. Okay, your height is 2 radius. So your radius is height divided by 2. Okay, so we replace or we substitute height over 2 for r square. So it becomes pi times h over 2 square times your height. Okay, your height here is not the part of this one. Your r square is h over 2 square times height. So h square, 2 square, 4. Okay, times height equals to 54 pi. So because there's pi on both sides, we can divide pi with each other. Okay, we can divide pi on the left, divide pi on the right. Cancel. Okay, but we cannot cancel the rest. So 4 over 3. So now h square times h is h to the power of 3. Right, because h times h times h. So h cubed over 4 equals to 54. Which means reverse 4 times 54 is h to the power 3, which is 216. So again, power cube reverse is cube root, right? Which is why we cube root 216, we get 6 cm. Okay, so because we have 6 cm, we know the height already, we need to find the base area of cylinder. So from here we carry on with the answer. Base area equals to 216 divided by 6. Okay, so let's pull out our calculator. Okay, split view, calculator. Okay, so we get 216 divided by 6, 36. Right, so from here, we will get the answer to be 36 cm square. So this is for part A. Okay, this is for part A. Part B is here. Okay, part B is here. So let me draw a line to separate the two. So now they want you to find the total surface area of the closed cylinder in terms of pi. So it's the same as the previous one. We know that there are two circles that we need to find. So pi r square times h times 2. Then we need to find the length, which is 2 pi r times h. Okay, so we know that r is height divided by 2, right? And since our height is 6, r is 3. Okay, so this is my r is 3. Okay, this is my h. Right? Okay, so we just sum in our values. 2 times pi times 3 square plus 2 times pi times 3 times 6. You get 18 pi plus 36 pi, 54 pi. So this will be your answer. Okay, for what example 14. Quite simple. Okay, what example 15 is just a more tedious question. Okay, first off, they ask you to find they have a metal cylinder disc of radius 4. Okay, so write down here radius 4, height 1.5 cm. Okay, then they melt and recast it into a cylinder bar of radius 2. Okay, so now they ask you to find the length of the bar. Right, so since it's the same item, just melt and remolded, right, the volume is the same. So we need to find the volume first of the metal cylinder disc. Okay, right, because we have the radius, we have the height, we can find the volume. So volume of this, pi r square, so this is area of circle, right, times 1.5, we sub in 4, we get 24 pi. Now this one doesn't ask you to leave it in terms of pi, but I'm just doing it, right, because it's a lot easier to calculate. Okay, so we want to find the length of the disc, right? We need to divide by the area of this bar, right? Because the disc is so much wider, right? Okay, so now we have the volume of the disc. We have to divide by the area of this bar. Okay, so we know that the radius of the bar is r equals to 2, so it's pi r squared. So this area of the circle for the bar. So 24 pi divided by pi, so the pi divided by pi will cancel, right? So it's 24 divided by 4, we get 6. So this L equals to 6. Okay, so this is why I leave it in terms of pi, because it's easier to calculate. Right, then they ask you to find the ratio of the total surface area of the disc to that of the bar, so it's the same thing. Okay, so you find two area of circles for the disc, right, the cylinder disc, plus the giant rectangle, which is your circumference of circle times height. Okay, I will get 44 pi. I do the same for the bar, right? It's just that the radius and the length is different, but if not, the method is the same. So 2 area of circle, the circumference of the circle times height, I get 80 pi. I find the ratio, okay, 44 pi to 80 pi, cancel with the pi, simplify by 4 and get 11 to 20. Okay, can? Should be quite simple, right, from this part, once you are familiar with the formula. Okay, the last one, when I will need to use the Tinkercad to help. Okay, the cylinder shows a cylindrical pipe. Now the pipe has an external diameter of r equals to 3 cm. Okay, so let's say I use a different r. So the external one, which is the longer one, right, this one, this is the diameter, right? So d equals to 3. The thickness is 0.3 cm and the length is 4. Okay, so find the internal radius of the pipe. So internal radius of the pipe is this one. Okay, internal radius of the pipe would be this one. Okay, so I use a small to represent an internal radius. So I just take 3 minus this one, right, and minus this one to find this internal diameter first. Right, I find the internal diameter, then I divide by 2. So your internal radius is 1.2. Okay, internal radius is 1.2 cm. Okay. Okay, so now they ask you the volume of the material used in making the pipe. Now, you need to find this area. Okay, you need to find this area. So, let me show you how I made a 3D model of this. Okay, using Tinkercad. Now, if you notice when I use Tinkercad to make this, okay, I actually made one here. Okay, the way to do it is like this. I take one bigger cylinder, okay, then I replicate this thing, right, and I make a smaller cylinder and I put it on top of the other one. Okay, then from here I merge the two. Okay, so I'm going to use a different color. Right, so you see that there's a mix here. Okay, so you may need to adjust this a bit so that it looks like it's a circle on top of a circle. Okay, so not so smooth. Okay, roughly lah. Okay, you get the rough idea. Okay, here it is. Okay, now I'm going to merge it. Okay, but I'm going to make this hollow. I'm going to make this hollow. I'm going to merge the two. This way. Right, and you see that it becomes a hollow cylinder. Right, this one the placement wasn't correct, so there's a cover at the bottom. Okay, look on the one at this one. Okay, so if we done it properly, actually we will get a straight through. So this is how the 3D model looks like of that diagram. Okay, so you realize there's an internal surface area and an external surface area, right? But what we want to know is how to find this area first. Okay, let's do it slowly. We want to find how to find this area. So just now when you notice when I created the cylinder model, you take the bigger cylinder minus the smaller cylinder. So we need to find the volume of the big cylinder, the volume of the small cylinder, the internal radius, and then we minus off. Okay, so the bigger cylinder, the radius is, I'm going to use R 1.5. Okay, the smaller one, radius here, 1.2. Okay, so when we sub in our values, this is the bigger cylinder. Okay, area of circle times your height. Right, both of them are 4. Okay, so minus the smaller one. Okay, this time I just use pi straight away to find the answer because they want it correct to 3 significant figures. So I get 10.172. So round up 3 significant, 10.2. Okay, so now they want your answers correct to 3 significant. They want to find the total surface area of the pipe. Okay, so now for this one, you need to imagine there are three parts to this, right? First off, you have your 2 circles. Two ring circles, right? Because this is a alright, then you have your external rectangle, right? The skin, the covering, the outside part of the cylinder, which is your external diameter is 3. Yeah. No, your height is still 4. Okay, but this is 2 pi r because this is the external one. Okay, then you have your other ring over here. Right, then you have your internal one, right? The internal one, which is not linked to this one. So I will draw a connecting one over here. So this is a bit smaller. Right, the height is the same, but it will be a bit smaller than the other one. Okay, so this is the internal one. So this is 2 pi r, the small r. This is the big R. This is the 1.2. This is the 1.5. Okay, so you have actually 4 parts of surface area to find. We already got the area of this ring, right? We got it here. Okay, we didn't get it. Okay, so to find the ring, we find the area of the big circle minus the area of the small circle. So pi r square 1.5 minus pi r square 1.2. Okay, so we get, this is the area of the ring. This is the area of the ring. Right, area of the ring. Okay, so times 2 because there are 2 rings. Right, so we found that already. Then we want to find the inner rectangle, the outer rectangle. So 2 pi r times height, and this is the inner one times your height. Add together 72.9. Okay. Now they say down here, okay, D, which has not been done. If water flows through the pipe at 8 cm square per second, find the volume of water that passed through in 25 seconds. So you have to imagine the volume is of water that passed through is 8 cm per second. So there's this amount of water. Can I get it? Sorry. There's this amount of water that's rushing through this point at 8. Alright, it's coming out at 8 cm per second. Okay, so they want to find the volume of water that flows through the pipe in 25 seconds, right? Okay, so all we need is we need the area of this circle, right, multiply by 8 cm times 8 cm times 25. Okay, so what do I mean? Okay, so basically what I'm saying is that at this point, right, the entrance of the cylinder, the water is coming out. So if it keeps coming out for 8 seconds at 8 cm per second, it means that in 25 seconds, the amount of water, let's say the water comes out this way, right? What is the length of the water that actually comes out? Let's say the water just carry on magically, right? It should be 8 cm per second times 25, right? So this will be the length of the water that comes out. So actually we're trying to find the volume of this cylindrical amount of water that's coming out. Let's say like a block of ice is coming out this way. Okay, your height will be 200 cm. Okay, so we just need to take the volume of the internal circle times 200 cm to find our volume of water that flows through. Okay, so I'm going to find D here. Draw a line down, draw a line here. Okay, volume of water. Okay, so we know our internal one is pi 1.2, right? So it's pi r square 1.2 square. So pi r square volume of water times your height. Height is 8 times 25 times 8 cm square times 25. Okay, so we get 1.2 square times pi times 8 times 25. We will get 904.778. 3 significant 905 cm cube. Okay, then you need to write down 3 significant figure. Okay, apologize for the lack of space. Okay, so once you find the volume of water, right, it's again just the area of circle times the length of water that goes through that point. Okay, so hopefully this helps. Any questions, please ask. All right.